So in this question, we want to look at how we sketch a quadratic graph when a domain is not given. Domain, remember, domain represents a set of x values. So here we are not given a set of x values so that we can make substitutions and get corresponding y values. So therefore, we need to find three basic things. We need to find where the graph cuts the y-axis, the x-axis, and the turning point. So first we want to find out where the graph cuts the y-axis. And this is done the exact same way when sketching equation of a line. Remember, when you're sketching equation of a line, the graph cuts the y-axis when x is 0, cuts the x-axis when y is 0. Alright, so graph cuts y-axis when x is equal to 0. When x is equal to 0, y equal to 0 square, which is 0. Negative 6 times 0, which is 0. So we're just left with positive 5. So it cuts the y-axis at 5. We need now to find out where the graph cuts the x-axis. The graph cuts x-axis when y is equal to 0. Now when y is equal to 0, what we have is 0 equal to x squared minus 6x plus 5. And we have a quadratic equation here, which we can solve using one of several methods. In this video, I'll be using the factorization method. So I'll factorize the quadratic and we equate both brackets to 0. So we want to rewrite the middle term. Remember, the two numbers you use to rewrite the minus 6 need to, of course, add to give you back minus 6 and multiply to give you AC, which is positive 5. And of course, we're using minus 1 and minus 5. So x squared, and we rewrite the minus 6x as minus 1x, and minus 5x, because minus 1 and minus 5 give you back minus 6, of course. And when I multiply those values, I get AC, which is positive 5. So we factor by groups now. So the first group, we factor out x is a common factor, and x minus 1. The second group, the common factor there is minus 5, since it begins with a negative term. And the same bracket, x minus 1. And of course, you can always expand the bracket just to ensure that the factorization is accurate. So here we have a common bracket, x minus 1 is a common factor there, x minus 1. And outside the brackets, we have x minus 5. So to solve this quadratic, we equate both brackets to 0. So we end up with x minus 1 equal to 0 and x minus 5 equal to 0. So solving, x equal 1 and x equal to 5. So these are the values where the graph cuts the x-axis at positive 1 and also at positive 5. The other thing we need to know now is where the graph turns, or the turning point. And the turning point, it's 1 point but 2 different coordinates, right? Notice we need an x coordinate and we also need a y coordinate. X coordinate we can get by using the formula, standard formula, works every time, negative b over 2a. Now look at the function, x squared minus 6x plus 5. The b value is minus 6, a value is 1, c value is 5. So b is minus 6, so minus b, that's minus minus 6, which is positive 6. And a is 1, so 2a is 2 times 1, which is 2. So that's 3. So the x coordinate for the turning point is 3. And to get the y coordinate, there are many ways to get the y coordinate, but we can just simply substitute the x value into the y equation to get the y coordinate. So we substitute y into x into the function, x equals 3. So x squared becomes 3 squared. And minus 6x becomes minus 6 times 3. So replace all the x values with 3 and plus 5. So this now becomes 3 squared, which is 9. And negative 6 times 3, that's minus 18 plus 5. And that works out to be minus 4. So the y coordinate for the turning point is minus 4. So the point is 3, negative 4. We plot that point. 3, negative 4. So 3 on the x. And 4 down. So from the origin you move 3 across the right and 4 down. That's the point 3, negative 4. And then we draw a smooth curve running through all those points we have on the graph. Let's change that, make a neater graph. Running through all those points that we mark there. Now, one thing CXC love to ask is for what we call the axis of symmetry. What is the axis of symmetry? It's a line that cuts the curve in two, and it's always found. It always runs through the turning point. Always. And this is a line. That's a line x equals 3, because this line cut the x-axis only at 3. So we can label this line x equals 3 is what we call the axis of symmetry. Alright. So again, we want to find out where the graph cut. The y-axis is always the c value. In this case, it's 5. And to find out where the graph cut the x-axis, you let the y be 0. And you have a quadratic equation that you can solve, whether you use a formula or factorization or completing square method. Alright, so 5, that's the way the graph cuts the y-axis, the value of c. Or you see when x is 0. And the turning point, notice the x-coordinate, negative b over 2a, which gives us positive 3 in this case. And then we substitute it into the equation to get the corresponding y value. In this case was minus 4. We plot the point 3, negative 4. So, that's it. That is all there is to graph in a quadratic function.